Hey, what's up YouTube? Today we'll be talking about estimating derivatives. So there are two ways in which we'll be estimating derivatives. The first one is called the Symmetric Difference Quotient, which isn't very important for your AP exams, but the second one is the Mean Value Theorem. So let's talk about the Symmetric Difference Quotient really quickly because this is still important for single variable calculus. So the Symmetric Difference Quotient is basically a different way of expressing the slope. So here's it written out that the f prime of a is, I should say approximately, because it's not equal. So f prime of a being the derivative of point A, so the slope of this tangent line, f of a plus h, so this point over here, minus f of a minus h, this point over here, divided by 2h, as in the change in x between a minus h and a plus h. As you can see, this is just a different way of expressing the slope, an average slope, I should say. If we said that this was point x2, and this is point x1, then we could see that this is really just the slope. Over here we have y2 minus, over here would be y1, over x2 minus x1. And then y2 is really just f of a plus h, because a plus h is this point x over here. So you could say that this is a plus h minus a minus h, which, as you can see, simplifies just to 2h, because you'll have minus a and then plus h, and then a minus a is 0, h plus h is 2h. As for y2 and y2 and y1, y2 would just be the function, this function over here, at a plus h, and we subtract it from the function at a minus h. So, as you can see, this is the slope formula, just rewritten in a different way. Now let's talk about the mean value theorem. So, I'm going to draw another graph really quickly. For the mean value theorem, just going to do it like this. Right. We have some point A here, and some point f of A right over here. Then we have some point B, let's say over here, and then some point f of B, like over here. So the mean value theorem says that there is some point C over here, where the derivative is going to be parallel to the average rate of change. By that I mean the slope of this line. At some point along this interval, there'll be a tangent line that is equal in slope. So let's try and find it. And I would say it's like right over here. It would be parallel. As you can see, that looks pretty parallel. I think the point C would be actually over here. Either way, that's not important. The point is that you can use this sort of theorem to say that there is some slope here along this line that's equal to the average rate of change. Now, the third one will be something that you'll be using on your AP exams all the time, and this one is just estimate what it would be in the middle. And I'm going to make this like a subsection because you find it in the same exact way. You just use two intervals and then find it. It's like a mixture of the symmetric difference quotient and the mean value theorem. The point is that the closer you get to this point, the more accurate it'll be. So if a plus h was over here and a minus h was over here, it'll be even closer to a. And then you also use the mean value theorem in the sense that you don't have to really think about a plus h, a minus h over 2h or whatever. You just think about it in terms of the average rate of change in between two points. So I'm just going to call this the average rate of change. And to give you an example, we're going to look at this question here from last year's AP exam. So it says water is pumped into a tank at a rate modeled by WT is 2,000 e to the negative t squared over 20 liters per hour on the interval 0 to 8, where t is measured in hours. Water is removed from the tank modeled by RT, liters in hours where R is differentiable, and decreasing on 0 to 8. Selected values of RT are shown in the table above. At time t equals 0, there are 50,000 liters of water in the tank. So we're going to be focusing on this question over here, A. We're not going to be doing B, C, or D yet. It says estimate R prime of 2. So 2 obviously is not on this table. So what we do is we find the average rate of change between 1 and 3. So what we get is we're going to do f of 3 minus f of 1 over 2, because 3 minus 1 is 2. And that'll be equal to f of 3 is 950, and then 950 minus 1190 is, well, we're just going to simplify it and do this. We get negative 240, so we get negative 240 over 2, and then that'll be equal to negative 120. And then obviously you need your units, and since it's the derivative, it's the rate, so liters per hour squared. So L per hour squared. Because remember, the slope is going to be liters over hours, so you get liters over hours times hours, which is liters over hours squared. And then we look at our answer, and we get the same exact thing. Thank you for watching. I hope you enjoyed this video. I'll see you on Monday with the new math video.